Hello, science classes. It's good to see you once again, and welcome once again to science virtually online. Today we're going to be wrapping up our chapter 4, with our science notes that you have in our notebook. And you will see attached to this assignment the notes that you need, which will be from page 105 and 106 and 107 of lesson 4 notes. First thing I'd like for you to do, though, is to grab your science books, your textbooks, and we're going to be looking at the planet Pluto, the minor planet Pluto, or the dwarf planet Pluto. So I'd like for you to turn to page 129 of your science books. And this article here on 129 is about the dwarf planet Pluto, and I'd like for you to read along as I read it to you. What in the world is it when it comes to Pluto? Since Pluto's discovery in the year 1930, students have learned that the solar system has 9 planets. But in the year 2006, the number of planets was changed to 8. What happened? Well, what happened was the discovery of information about Pluto, as you can see here on the screen. Neil deGrasse Tyson is an astrophysicist at the American Museum of Natural History in New York City. He and his fellow museum scientists were among the first to question Pluto's classification as a planet. One reason was that the planet is smaller than the 6 moons in our solar system, including Earth's moon. Another reason was that Pluto's orbit is more oval-shaped or elliptical than the orbits of the other planets. Also, Pluto has the most tilted orbit of all the planets, 17 degrees out of the plane of the solar system. Finally, unlike other planets, Pluto is mostly ice. Tyson also questioned the definition of a planet, an object that orbits the sun. Then shouldn't comets be planets? Because they orbit the sun. In addition, he noted that when Ceres, an object orbiting the sun between Jupiter and Mars, was discovered in 1801, it was classified as a planet. But as astronomers discovered more objects like Ceres, it was reclassified as an asteroid. Then, during the 1990s, many more objects similar to Pluto were discovered. They orbit the sun beyond Neptune's orbit in a region called the Kuiper Belt. These new discoveries led Tyson and others to conclude that Pluto should be reclassified in the year 2006. The International Astronomical Union agreed. Pluto was reclassified as a dwarf planet, an object that is spherical in shape and orbits the sun in a zone with the other objects. Pluto lost its rank as the smallest planet, but became king of the Kuiper Belt. So that is the story of the planet Pluto. At this time, I'd like for you to go ahead and turn into your notes to page 105. It is attached if you do not have a frog book like success students do. And today we're going to be looking at lesson number 4, dwarf planets and other objects. And the vocabulary that we will need to know is meteoroid, meteor, meteorite, and impact crater. So let's get started looking at page 105 of your notes and start our discussion on the dwarf planets. Write this down. I found this on page 131. So if you turn to page 131, you will see this image of the 4 dwarf planets that we have listed in our book, plus the Earth's moon. According to the International Astronomical Union, a dwarf planet is an object that orbits a star and has enough mass and gravity to pull itself into a spherical shape. So write this down for our compare and contrast of what a dwarf planet is in this Venn diagram. A dwarf planet, write this down, is an object that orbits a star and has enough mass and gravity to pull it into a spherical shape. So how is that different than a normal planet? For a normal planet, unlike a normal planet, a dwarf planet has objects similar in mass orbiting nearby or crossing its orbital path. So a normal planet, write this down, has mass greater than all the objects nearby. A mass greater than all the objects orbiting nearby. So dwarf planets are objects of similar mass that orbit near or across its orbital plane, and a regular planet is a planet that has a total mass of all the objects whose orbits are close by. It is greater than that. So what is both objects? Both objects would be two things. Number one, spherical. So write in the both section the word spherical. And number two, both objects orbit a star. Number one, spherical. Number two, both objects orbit a star. So dwarf planets are different because of the fact that their mass is smaller than the objects that are around it. The smallest of the dwarf planets is Ceres. So let's look at the chart that we can see there on page 132 of our book, the information from 132. And we have a chart in our notes of organizing information about the dwarf planets, just 3 of them. So let's talk about Ceres first. Ceres, its location is in the asteroid belt. So let's look at Ceres on solarsystem.nasa.gov and see what that looks like. So Ceres is the smallest of all the worlds, and this is what Ceres looks like up close. We've looked at this a little bit, and you'll notice that Ceres looks very similar to a moon. It does have a lot of asteroid impacts on it, or meteorite impacts on it. So for Ceres, it's in the asteroid belt. It has a rocky core surrounded by ice. So this white area is ice. So write that down for composition for Ceres. A rocky core surrounded by ice. The number of moons that Ceres has is 0. That we are aware of. Now let's move on to Pluto. Pluto, again, we've looked at this on this solarsystem.nasa.gov. Write down this location. It's in the Kuiper Belt, which is outside the orbit of Neptune. In the Kuiper Belt. Kuiper, K-U-I-P-E-R, Kuiper Belt. The composition is the same as Ceres. Rocky, surrounded by ice. We see some of these smooth areas on Pluto. It is ice. And the number of moons, you should have there 5. Or mark out if there is another number there. They have changed the number of moons to 5 for Pluto. And now let's go to the last one that's in our note, and that is Eris. Eris is 3 times further from the sun than Pluto. That is its location. 3 times further from the sun than Pluto. This is our best image of Eris. Composition, rocky, surrounded by ice, just like Pluto, just like Ceres. And Eris has 1 moon that we are aware of. 1 moon. So Ceres is the smallest dwarf planet with a diameter of about 950 kilometers. Pluto is so far from the sun that it takes about 248 years to complete 1 orbit. And Eris is the largest of all the dwarf planets. So then that leads us to two other worlds that we have not yet talked about. And that is the world of Makemake and Haumea. So let's look at Makemake and Haumea at solarsystem.nasa.gov. First of all, Makemake. Makemake's best image looks like this. Along with fellow dwarf planets Pluto, Eris, and Haumea, Makemake is in the Kuiper Belt. And it's a region outside of Neptune. It takes about 305 Earth years for this dwarf planet to make one trip around the sun. It has a 22.48 hour day, so it spins very similar to planet Earth. And Makemake was discovered in the year 2005. And then the last world that we like to visit for the dwarf planets is the dwarf planet Haumea. Haumea, also located in the Kuiper Belt. It is 385 miles in radius, and it has two moons, Namaka and Hiaka. A day on Haumea lasts only 4 hours. It is one of the fastest rotating objects in the solar system. So, describe Makemake and Haumea. I would say they're both dwarf planets, smaller than Pluto, and found in the Kuiper Belt. Write that down for your last note on 105. Both are dwarf planets that are smaller than Pluto and found in the Kuiper Belt. And you found this answer on page 132 of your science book. Now let's move on and talk a little bit about asteroids. So go on to page 106 of your notes and have your textbook open to page 133. Asteroids, there's a lot of them. Most asteroids orbit the sun in a belt between the orbits of Mars and Jupiter. So for location on this first note on 106, on facts about asteroids, you will put in there, they are located between Mars and Jupiter. How many of them? Well, we can be very specific if we, again, go to the solar system page and we look at asteroids. And let's just see how many that we have. At this point, if you want to be very, very specific, there are 1,027,641 known asteroids. 1,027,641 known asteroids. So there's a lot of them. The next note is, what do they look like in description? I would write down chunks of rock and ice. So they're big chunks of rock and ice. And here you can see an image of 4 of the asteroids that are in the asteroid belt. Let's talk about those real quick. Upper left is Meteors. It's about 66 kilometers long and 47 kilometers wide. Ida is about 58 kilometers long, has a small moon. Eros is about 33 kilometers long. The Near Space Probe landed on this asteroid in the year 2001. And Vesta is about 530 kilometers wide, and it's the second largest asteroid. So what is the largest asteroid? That's your next note. And I do not have a description of this on the screen, so you just have to listen. The largest asteroid is the asteroid Pallas, and it's spelled Pallas. And it's 500 kilometers in diameter. Pallas, 500 kilometers in diameter. So asteroids are these clumps of rock and ice that never clump together to form a planet. Some astronomers think the strength of Jupiter's gravitational field might have caused the chunks to collide so violently that they broke apart instead of sticking together. So that is our discussion of the facts of the asteroids. Let's move on and talk a little bit about comets. And how are they different? And this also is found on page 133 of our book. Compare and contrast asteroids and comets by completing this chart. Let's talk about how they are same. Asteroids and comets are the same. And you have 2 bullet points there. The first bullet point is that the asteroids and the comets both orbit the sun. Write that down. Both orbit the sun. Your second bullet point, both are made of rock, ice, and dust. Both are made of rock, ice, and dust. Then how are asteroids and comets different? Your first bullet point on the different column, comets have tails, as you can see in this description. Comets have tails that are more than 100 million kilometers long. And these tails are caused by the blowing of something called the solar wind. The solar wind, which is energy from the sun, hits the comet and it starts to melt the ice, and the ice turns into a vapor, and also the rock and dust will leave the comet and it will form a tail like this, and you'll see in this image a gas tail and a dust tail. So sometimes it's like a twin tail. Some of it is gas, some of it is dust. So comets have tails. That's your first bullet point. The second bullet point is comets have greatly elongated orbits. Comets have greatly elongated orbits. Elongated. E-L-O-N-G-A-T-E-D. Comets have greatly elongated orbits. In other words, as you can see in this image, that they go way out past the sun and then they'll fly in close to the sun, where the asteroids remain in the asteroid belt. What I'd like for you to do now at the bottom of 106 is I'd like for you to draw the model that you see up on my screen, and you can pause the video right here if you would like to. I would like for you to put multiple comets in. As you can see in this image, I can count 5 of them in different locations, and draw the tail so it's blowing away from the sun. And I'd like for you to label one of the comets with a coma, which is the center of the comet, and then the gas tail and the dust tail. So go ahead and spend a couple of minutes doing that at the bottom of page 106 by looking at this attached diagram that you see on my screen. Go ahead and pause the video now to complete this drawing, and then restart the video when you're ready. Now we're going to move on and finish looking at what comets appear to look like. Here you can see a close-up of that coma, the dust tail, and the gas tail. The visible parts of a comet are these 3 parts, and the comet's coma surrounds the nucleus, or the rocky core of the comet. This is an image of the nucleus of a comet called Wild 2. It was taken by the Stardust space probe. The nucleus was too far from the sun to have a bright coma. And you can see it just looks like basically almost like an asteroid. So the particles in a comet are loosely held together by gravitational attractions among the particles. And the comets orbit the sun in a stretched out elliptical orbit. The solid inner part of the comet is called its nucleus. And as the comet moves closer to the sun, it heats up and can develop a very bright tail. So that's what a comet is like. Let's move on to our notes now. and go to page 107 of your notes. And I'd like to talk about two different types of comets that we have. And this answer is found on 134 of your book. Distinguish information about the source of comets below. And the first sentence starts out this way. The Kuiper belt is, finish the sentence, it should say, the source of short period comets. The source of short period comets. These are the comets that will fly out past Neptune and turn around and fall back toward the sun. For example, the famous Halley's Comet takes about 76 years for it to go out and then come back in closer to the sun. The second sentence is the Oort cloud is the source of the long period comets. The Oort cloud is way out past Pluto. And these are comets that may come back every 1,000 or 1,200 years. So they're very rare for anyone to see them, and then they disappear and never to be seen for 1,000 years to come. So obviously there's different people on the planet when they come back, and it's hard to tell if they're the same comet. All right, let's go down to the next section on meteoroids. And this answer is found on 134 of your book. Analyze the differences between a meteoroid, a meteor, and a meteorite by completing this chart. So we're going to write down what it is. Let's start off by meteoroid. If you'll look at the slide now, a meteoroid is a small rocky particle that moves through space. So copy that down in your notes. A small rocky particle that moves through space. A meteor, this would be your next note, is a streak of light in the Earth's atmosphere made by a glowing meteoroid. So it's only a meteor once it hits the atmosphere of Earth and starts to burn. So a meteor is a streak of light in Earth's atmosphere made by a glowing meteoroid. And then the last note is meteorite. A meteorite is a meteoroid that strikes a planet or a moon. So once they hit the ground and survive, then they're called a meteorite. And meteorites are very valuable. People find them all over the planet. And if you get a chance, do a Google search on meteorite. So a meteorite is a meteoroid that strikes a planet or moon. The next note says describe an impact crater and how it is formed. And this is what you can write down. An impact crater is a round depression formed on the surface of a planet, moon, or other space object by the impact of a meteorite. So I'll give you a few minutes to copy that description down. So a round depression formed on the surface of a planet, moon, or other space object by the impact of a meteorite. So that concludes this section of the notes. We have one more question to answer on 107, so let's go ahead and do that right now. Analyze it. Which attribute is more important in classifying a solar system object? Its size or its composition? And explain. So when we're looking at a solar system object, the most important attribute would be size. So write this down. The most important attribute in a solar system object is its size. The size determines what it will be called. Is it a planet, a dwarf planet, an asteroid, a meteoroid? What is it called? A comet? It all depends on its size. After we look at the size, then we can start looking at the composition. So write this down. The most important attribute in a solar system object is its size, because we look from larger to smaller objects in the solar system. And that wraps up our notes for this chapter. Now, I would like to announce when the next science test will be. The next science test will be a week from tomorrow, or on Tuesday. And it is my hope that we will be back at school at that time to take that test. I will be posting up very soon the study guide, and it will be placed on a week from Tuesday's calendar. So look for the Chapter 4 study guide coming up very soon on Canvas calendar. There will be no homework for Monday other than these notes that we took today. You do not need to email your notes to me. Just save your notes on your iPad. Later, we will print them out at school and we will put them in your notebook. I will be assigning some homework later this week on Tuesday and Wednesday, different worksheets to review this chapter with you and kind of get things wrapped up over the next several days. And I may have a few more videos for you to watch from YouTube. So that concludes our notes for Chapter 4. I hope that you have a great week, and I hope to see you 1 week from today back at school if nothing else changes. Hang in there, guys, and it's great seeing you once again, and we'll talk to you very soon.